To calculate a one-sided upper-tailed t-test and determine if the mean SAT score for females is greater than the mean SAT score for males, let's submit this PROC-T-test step. The log shows that SAS processed the code without errors. Here are the statistical tables. Let's start by looking at the mean diff value of 60.75. This is the point estimate for the difference between female and male SAT scores, and it confirms that it makes sense to perform an upper-tailed test. Great! Next, because you failed to reject the assumption of equal variances in the previous demonstration, which p-value should you examine? You use the pooled method p-value, which is 0.0321. Assuming your alpha is 0.05, do you reject or fail to reject the null hypothesis? The p-value of 0.0321 is less than 0.05, so you reject the null. This means that, statistically speaking, the average SAT score for females is greater than the average SAT scores for males. If you look at the confidence interval for the differences between the means, 6.8651 to positive infinity, it does not include 0, so the difference of the means is significantly different from 0, with females scoring higher than males on average at the 95% confidence level. You learned the same thing from the p-value. Lastly, the difference interval plot reflects the one-sided nature of our analysis. This time, the confidence interval does not cross over 0, and this also tells you that there is a difference in male and female SAT scores, specifically that females scored higher on average than males.